Okay, now let's look at this demonstration here, setting up the experiment that I did earlier with a laser pointer. To be able to create the interference patterns using method 1, you need a laser pointer on which you're going to mount in the center of the aperture a very fine piece of wire. Then you aim the laser pointer towards a light color wall which you're going to use as screen. Once you have your laser pointer set and aimed towards the screen, you need to move far enough so you will see the interference fringes on the wall. Once we have the fringes on the screen, we'll be able to measure the parameters that we'll need to use in our calculation later on. The distance between two dark spots, the distance between the laser pointer aperture and the screen, and we'll be able to calculate the diameter of the wire provided we know the wavelength of the laser pointer. So let's look at the example with measurements that we took here in the lab. The wavelength of the laser pointer was 532 nanometers. That was a green laser. The distance between the laser pointer and the aperture was 11.52 meters. And then the distance between the two adjacent dark fringes was 12 millimeters. Putting everything into this equation and carefully working with units, make sure that all of our units of length are in meters. We do the calculations and we ended up with 511 micrometers, which compares very favorably with the actual wire diameter, which was 500 micrometers.